We have learned on how to use matrices to solve simultaneous equations for both 2 unknowns and 3 unknowns. Now let's look at how we can apply matrices for 2-dimensional and 3-dimensional transformations. Now there are 3 forms to this. The first is translation, and translation moves an object from one position to another. The second is scaling. The scaling can enlarge or shrink or reduce an object. And the last is rotation. So the rotation rotates an object around the origin by an angle theta. Now you might be asking, what is 2D, what is 3D? 2D simply means 2-dimensional, and 3D simply means 3-dimensional. So 2-dimensional involves 2 column vectors or 2 forms of unit vectors, x and y, and the x and y can also be I and j. And 3-dimensional involves 3 x, y, and z, which can be represented as I, j, k. So just a quick review. 2-dimensional vectors can be written, let's say an example of 2-dimensional vectors is 2i plus 3j, and in terms of matrix is written as 2, 3. Let's take another example. We have 4i plus 6j is going to be written in the format of -4 and 6. Right, so we consider the first column as x and we consider the second column as y. In the same vein, if you have 3-dimensional vectors, let's say we have 2i plus 3j minus k, is going to be written as 2, 3, and -1. So we have x, we have y, and we have z. Now this represents a point. All this represents a point. Now a line rather, is the combination of 2 points. So if I have 2 points, let's say I have 2, 3, -4, and 6. So I can call this a line vector, because 2, 3 can be a point, -4 and 6 can be another point, and then when it comes together they form a line. So in the next video we will learn on how to use translation, and afterwards we'll learn scaling and rotation. We will learn them both in 2 dimension and in 3 dimension.